Are you ready, kids?
Aye, aye, Captain!
I can't hear you!
Aye, aye, Captain!
Oh!
Stoichiometry is the study of quantitative relationships between reactants and products. The limiting reactant of a chemical reaction is the reactant that runs out first and determines when the reaction ends, ultimately limiting the amount of product produced. It is easy to explain this when referring to recipes. If we have 4 buns and 10 patties, and each Krabby Patty needs 2 buns and 1 patty, we are only able to create 2 Krabby Patties due to the limited amount of buns. Because the buns limit the amount of Krabby Patties made, it is the limiting reactant in this equation. In this lab, we will need to define some key players in this reaction. 1 is precipitate, a solid that is formed from a liquid solution, and 2 is supernatant, the liquid located above the precipitate or solid within a chemical reaction.
Today we will be observing the reaction between 2 aqueous solutions of copper sulfate and potassium hydroxide, which were made by Mr. Mitchell beforehand. We will observe this reaction in different ratios and then collect a series of data on the precipitate form. This data will then be used to determine the limiting reactant at different ratios. The reactants for our experiment are aqueous solutions of copper sulfate and potassium hydroxide. We notice that copper sulfate is a clear light blue liquid with a thin density, while potassium hydroxide is also a clear liquid that's colorless. To create a chemical equation, these reactants will go through a double displacement reaction. In this type of reaction, the cations of each compound will switch. For instance, since the cations in the reactions are copper and potassium, they will take place of one another. This will create products of copper hydroxide and potassium sulfate, and then to balance the equation, we will add a coefficient of 2 in front of potassium hydroxide, creating the final balanced chemical equation.
We started off by cleaning each of the test tubes with a pipe cleaner to ensure that there were no leftover chemicals to inflict on our experiment. We then dispensed 5 milliliters of CuSO4 into all 8 tubes. Then we added KOH to all tubes according to the volume chart. Then we added distilled water to all the tubes so that they all had a solution of 13 milliliters.
The test tubes were all started with a glass stirring rod and were set aside to sit for 15 minutes. In the time lapse, you can observe the physical chemical reaction occurring. The precipitate in test tubes 1 to 5 looks opaque and has a pale blue color. Test tubes 6 through 8 have a darker color and a clearer blue precipitate. As solids settle, we were able to analyze the compounds within the equations and notice their change in their composition.
In test tubes 1 through 4, the limiting reactant is KOH because the amount of KOH increases while the amount of CuSO4 remains the same. This also causes an increase in production. In the test tubes 5 through 8, the limiting reactant changed to CuSO4 because the amount of the product levels off as the amount of KOH increases and CuSO4 amount stays the same. In test tubes 1 through 4, the height of the precipitate went from 5.5 to 17.5. However, at test tubes 6 through 8, the precipitate skyrocketed to 59.0 milliliters for test tubes 5 and 80.0 milliliters for both test tubes 7 and 8.
We noticed an error in our reaction for test tube number 5, which was an outlier, due to the fact that it did not produce as much product as we expected. This is most likely resulted from slightly incorrect measurements of the reactants, which caused the production to be limited in this sample. If our measurements were perfect, the test tube 5 would have produced a similar amount of product to test tube 6 through 8. To conclude, this lab explained the idea of limiting reactants at different ratios and their definition within chemistry. We learned that reactions do not always form the amount of products as specified in a simplified balanced equation, overall allowing us to further our knowledge on stoichiometry and chemical reactions.